Okay, so this is the question just now I mentioned, where we will look further into the impact of the load resistance. Okay, so now we have a circuit like this, where you have a 4K resistor here. Okay, and you are connecting a load against this across this 4K resistor. Okay, and they want you to analyze what will happen when you go through different types of load resistance. So the first one is R is infinity, that means open circuit. If it's open circuit, then no problem, right? That means no current flows here. So the voltage is the open circuit voltage across that 4K. So it's 4,000 plus 1,000 times 100 volt. Okay, so you will get 80 volts. Okay, and since it is open circuit, your current will be 0. Okay, so there is no current flowing here because the load is open circuit. Okay, so that is when the load is open circuit. Now, how about when R is 8,000? So when R is 8,000 ohm, then basically what you need to do is you need to combine this to a single resistance. Correct? So you know the effective resistance. So what you have is 4,000 parallel to 8,000, which will give you 2667. Okay, so all this calculation you should know how to do. The parallel, series, all this thing. So if this is 2667, then your circuit then becomes like this only. Right? One resistor here, another resistor here, where this is 1,000 ohms and this is 2667 ohms. And what you want is to find this voltage. Okay, so the voltage here would be, again, using voltage divider rule. Okay, and the current, okay, current through the load will be the voltage over the resistance, 72.7 over 8,000. So this is the current through the resistor. That means when I connect a load. Okay, when I connect a load here, what is the current that flows through? Okay, sorry, this is the effective resistance, but when I connect the load over here of 8,000 ohm, then what is the current that flows through? So that will be 9.09 milliampere. Okay, and you do the same thing here. So R is 200, you do the same thing. So you get, so this will be 200, and then you calculate the parallel resistance. 200 parallel with 4,000. Okay, and you get 190 ohm. Okay, and then the effective voltage will be 190 over 190 times plus 1,000 times 100 volt, which will give me 16 volts over here. And the current would be 16 by 200, 80 milliampere. Okay, so one thing you would have observed either through the experiments and so on, whenever you have two resistors in parallel, if one resistor has a low value and the other resistor has a high value, the effective resistance will go towards the low. Okay, so you can see here as an example. When I have 200 parallel with 4,000, the effective resistance actually goes closer and closer to the lower resistance value. Okay, whereas if I have higher values, okay, even this, okay, it will always, so whenever you have resistors in parallel, the end result will always be closer to the lower value. So over here as well, 4,000 and 8,000, the end result is 2667, which is closer to the lower value over here. Okay, so that goes by the way the resistance formula works, right? When you have resistance in series, they all add up. Okay, and you have a higher resistance. When you have resistors in parallel, the effective resistance actually goes down. Okay, so that is, I think, something you would also observe in the studio as well. Okay, the last one. Okay, when you create a short circuit. So when you create a short circuit, what happens? Okay, when you create a short circuit over here, okay, effectively the circuit becomes like this. Okay, 1000 ohms and nothing. Okay, why nothing? Because when the current flows here, okay, when the current flows here and it comes to this node over here, it sees two pathways. One is through the 4K resistor, the other is the short circuit. And you always have to remember this very simple rule. Current will always take the easiest path. Okay, always take the easiest path to get back to the closed loop. Okay, so when it sees two pathways of 4000 ohm and a short circuit, it will always take the short circuit. It is the same concept as when you have two resistors, one very high and one very low. More current is going to flow in the lower resistance compared to the higher resistance. Okay, so it always takes the easier pathway. So when you have an option of a resistor value and a short circuit, you will always take the short circuit. So this 4K resistor will be totally bypassed. Okay, so the only current that flows in your circuit will be 100 over 1000, which is 0.1 ampere. Okay, and the voltage is of course going to be zero, because when you try to connect your voltmeter across a short circuit, okay, you read as zero because there is no voltage drop across the short circuit. Okay, so the voltage across the load here will be zero. Okay, so that is basically giving you an idea of how when you connect a load across a resistor, it sort of has an impact on the voltage and the current that you will experience.